going to understand the concept of cardiac conduction. See, basically, there is one thing that you have to understand. The heart is made up of muscle. Heart is a muscular structure. Heart is a muscular structure. Right, and the muscles, they are any muscle. What happens, it has got a feature. Muscles feature is to contract and relax. So the muscle of the heart, which is your cardiac muscle, its feature is to contract, undergo regular contraction and regular relaxation. Right, now when cardiac muscles contract, what it does, there is the contraction of not just the muscles. This results in the contraction of the atrium and ventricles. The atrium and also the ventricles will contract, and this results in the pushing of the blood. This results in the blood flow out of them. Blood flow out of them. Out of what? Out of the atrium and ventricles. That is, from the atrium it will go into the ventricles. We'll just put it that also here. So it will be from atrium to ventricles, and from ventricles to the systemic trunk or the pulmonary trunk. Okay, and when the heart is under relaxation, when we say it is under relaxation, that means when the cardiac muscles are under relaxation, that means what? The atrium and ventricles relax. Atrium and ventricles relax, which results in what? This results in inflow of the blood. This results in inflow of blood. Okay, so when the heart muscle is contracting, that means the heart is contracting, which is pushing the ventricles and atrium. When they're contracting means when they're squeezing themselves. When they're squeezing, I mean, take a balloon filled with water, squeeze it. When you squeeze the balloon, what happens? The water flows out. So when the atrium squeezes out, the blood will flow from atrium to ventricles. When the ventricles squeeze out, the blood will flow from the systemic trunk or to the pulmonary trunk. But when the ventricles and atrium are relaxed, when the cardiac muscle is relaxed, then the blood will enter into the atrium and the ventricles will stop sending the blood. Right, so contraction of heart muscles is in turn associated with the contraction of the heart itself. Now, heart, it is actually myogenic in nature. The cardiac muscle or the heart muscle that we call, it is myogenic in nature. Myogenic. Okay, listen to this word. It's an important word. Normally, muscles are voluntary. That means they are under the control of the brain. So whenever they receive and for contraction and relaxation, they need an impulse which comes from the brain. Right, but heart muscle is myogenic, means it generates its own impulse. It generates its own impulse. It is not dependent on the brain to send an impulse for the muscle contraction and relaxation. Okay, so this feature is called as automaticity or autorhythmicity. Automaticity or autorhythmicity. In this, what happens? The impulse that is necessary for the contraction of the muscles on its own and relaxation of the muscles is generated by the muscle itself, and that nature is called as, that muscles are called as myogenic muscles, and that nature is called as autorhythmicity. So that means heart is not under the control of the brain. Normally what happens is, if you ask any doctor, they say if a person is brain dead, they can still keep the person on a ventilator to keep his heart beating until the organs are harvested for organ donation. Right, but So that means what? Even if the brain is not working, the heart can be made to run using a machine. See, does that mean brain has no control over the heart? No, that is also not entirely true. The impulse to contract and relax is coming from the heart muscle itself, but the number of beats, okay, the number of beats, the times of contraction, how many times it should contract and relax, okay, the speed of contraction, the speed of the contraction means speed of the impulse. All of these features, they are under the control of the neural and hormonal, they are under systems, they are under neural and hormonal control. See, when we fear something, okay, you have adrenaline rush, adrenaline hormone becomes more, then your heart starts to beat erratically, right? So that means when adrenaline hormone is going up, your heartbeat is increasing. So that means the number of beats is controlled by the adrenaline hormone. But whether it should beat or not is not dependent on the hormone or on the brain. Okay, so the impulse generation, the impulse to, the signal to contract, the signal to relax, what is this impulse? Impulse is nothing but the signal of contraction and relaxation. So that signal of contraction or relaxation is generated within the heart muscle itself, and that's why it is called as the biogenic heart, which is showing the feature of automaticity or autorhythmicity. Now, what kind of impulse are we talking about? This impulse is completely depolarization of the muscle. This impulse is generated from the depolarization of the muscle. It starts from the muscle and spread one muscle and spreads through the entire heart muscle. So what is depolarization? Normally when you have it a charge, an electric charge in the cell, let us say this is a cell, okay, and if the electric charge of the cell is negative, now when this electric charge is changing from negative and it is going to positive, that means this muscle or this cell is undergoing depolarization. So depolarization is change in the electric charge within the cell where it goes from negative to positive. And repolarization means what? Repolarization means when a negative charged when a positive charged electric cell returns back to its original charge of being negative, then it is called as repolarization. So this depolarization, it results in the contraction, it results in the contraction of the muscles, and repolarization results in the relaxation of muscles. All right, now for this concept, this entire concept of the heart to generate, generate and conduct its own impulse, it comes under the category of what we called as cardiac conduction. So when we say of the word cardiac conduction, we are understanding how the heart muscle is generating its own impulse, conducting it throughout the heart. And when it is conducting throughout the heart, what it is resulting? It is resulting in the contraction and relaxation of both atria and ventricles. And when this is happening, you're having the blood flow. That means this is literally associated with the heartbeat, right? Because when the atria and ventricles contract and relax, they are associated with a thing called cardiac cycle, which we'll see later. So when this cardiac cycle happens, only you have heartbeat. So the beating, the functionality of the heart and the generation of and the movement of the impulse is what you are studying under cardiac conduction. Now there are three specialized structures, more specifically, which are involved in this cardiac conduction. The first structure is the SAN, which whose full form is sinoatrial node. Sinoatrial node. Now this one is present near the almost near the superior vena cava in the right atrium. So we can say this is present near the right atrium. Okay. The next one is our AVN, which is the atrioventricular node. Ventricular node. Next, the third one is the AVB, or the atrioventricular bundle. Now both of these are present in the interventricular septum. Interventricular septum. Okay, so these three are the main structures. Now together these three they belong to a common group of structures called as conducting tissues. They are the conducting tissues. Means what? They are basically the cells or the conducting nodes or conducting nodes which generate and conduct the impulse. Along with it, you have another set of muscles called as the contractile muscles. With contractile muscles, you can, instead of tissues, you can call them conducting muscles. Conducting muscles. Okay. Now, contractile tissue muscles are what? They contract upon the impulse. Contract upon receiving the impulse. That means as soon as they receive the impulse, they undergo depolarization and contract. So one conduct the impulse, the other one contracts based on the impulse. So these are the four things that are important. So now let us see how this cardiac conduction works. So let us see how the cardiac conduction begins, and it will begin obviously with the SAN node. Now as I have discussed, this sinoatrial node, it is located on the right atrial wall, just lateral to the opening, lateral and opening to the superior vena cava. Means literally it is present on the right upper hand corner somewhere here. Okay, so this is my SAN node. This is my SAN, that is the sinoarterial node. Now this sinoarterial node, what happens as soon as the autorhythmicity, that means this one, it continuously starts to generate impulses, and these impulses are for depolarization, right? So that is why this SAN, it is also called as the pacemaker of the heart. The SAN node is also called as the pacemaker of the heart. It is the pacemaker of the heart because it acts without nervous stimulation, and it is doing self-exciticity. It is doing self-exciticity without nervous stimulation. Okay, so what it does, it generates signals. What kind of signals? These signals are signals to contract, which are slowly spreading throughout the atrium. Now, along with the right atrium, let us label this. This is the right atrium. This is the right ventricle, left ventricle, and left atrium. Now, this SAN, whatever impulse that has been generated, of course, it is being generated throughout the right atrium. Okay, simultaneously that work is going on. At the same time, the impulse has to move through to the left atrium also. It has to go to the left atrium also, and from there in the left atrium, the impulse will be moving completely towards the entire muscular structure of the left atrium. Okay, so this generation of the impulse from the right atrium to the left atrium is caused by this group of tissues or bundle, which is called as the Bachmann's bundle. It is called as the Bachmann's bundle. Okay, Bachmann's bundle or Bachmann's is a group of tissues that help in conducting the signal. Where is it conducting from? It is conducting it from the right atrium to the left atrium. Right. Now, at the same time, these signals are what? These are depolarization signals. So, slowly the depolarization signal, it reaches through the entire walls of the left atrium and the right atrium like this, causing the contraction. Okay, contraction of the atrium. At the same time, this signal will slowly move as their atriums are depolarizing. The signal will slowly move to an area in the interventricular septum, and this is just, yeah, like this. It will slowly move to the area in the interventricular septum to a node, and this node is called as the AVN, the atrioventricular node. Now, the impulse in the AVN node, it becomes a little bit slow because the diameter of the conducting fibers or the conducting cells that we call about it, they are very less in the AVN node when compared to the SAN node. Now, next what happens is the signal will move from AVN node to another small little bundle which is called as the AVB bundle, or another name for this is the bundle of hiss. Yes, it's not HIS hiss, but hiss, like a snake's hiss. Okay, so the signal moves into the bundle of His, and this bundle of His, it remains like a bundle for some time, till some time, and then it separates into two distinctive fascicles, one towards the right and one towards the left, like this. Okay, so these are called as the right fascicle. This is called as the right ventricular fascicle, and this is called as the left ventricular fascicle. So the signal will, from the bundle of His, it will move this time faster because the diameters of the bundle of His and the fascicles are broader. So the signal will move faster and it will move all the way to the fascicles, and from the fascicles will be halfway through the ventricle. In fact, this is halfway through the ventricle, right? These fascicles, they become branched off like this. Okay, the fascicles, they become branched off, and these branched off structures, they are called as the Purkinje fibers. Purkinje fibers. Okay, and what happens to the signal? The signal will now move from the fascicles. It is moving from the fascicles to the through the Purkinje fibers, and it is reaching through the entire ventricle, and very fastly it will move, and this results in the repolarization of the ventricle. So slowly the ventricle will start to receive the signals of depolarization, and it will start to contract. Right. So this is how the entire conduction pathway is working. Now let us see the timings in this conduction pathway. Now, in the conduction pathway, as we have discussed, the signal starts from the SAN and it moves all the way to AVN node. So SAN, that is the pacemaker, to the AVN node. Then from AVN, it goes to AVB, that is also called as the bundle of His, and from there it goes to the Purkinje fibers. Okay, now normally there will be a slight delay in the movement of signals here from the SAN to SVN. Now the speed of the signal passing in the SAN node is 50 milliseconds per impulse. Every impulse takes 50 milliseconds. The same it will take 100 milliseconds per impulse in the AVN node. Because of the smaller diameter, it is getting slower. And in the bundle of His and Purkinje fibers, it is 75 milliseconds per impulse, and it can go as slow as almost to, all right, just leave it at 75, right? So there is this slowing, this delay is happening. Why is this delay happening? Due to the small diameter, due to the small diameter of the AVN fibers. Also, there will be a small delay. Normally, if I just put 3 seconds, let us say on a map, or I will draw a map like this, and in this map I'm jotting 3 seconds. 1, 2, 3. At each second, let us say I am having an arterial contraction. The pink ones represent the arterial contractions. Simultaneously, I'll have a ventricular contraction. The blue one are the ventricle contraction. In fact, there is a considerable amount of delay between the arterial and ventricle contraction, even though they are happening at every second. This delay is 1/10 of a second, or 0.1 seconds of delay. That means the impulse from the SAN node to the AVN and AVN, it has a delay of 0.1 seconds in between. This delay is very helpful to maintain a balance where both the arterium and the ventricles don't contract together. If there is no such delay, then the ventricles will contract at the same time the arterium are contracting. Then the blood from either of them is actually splashing with each other and mixing with each other. They are not going anywhere. It is just flowing in the heart, right? So after atrium starts to slowly repolarize and there is relaxation, then if the ventricles contract, there will be no simultaneous squeezing of the blood from both of the chambers, right? So that's why you have that 0.1 second delay, and that second delay is further helped by the small diameter of the AVN fibers. By the time the signal moves from the AVN to the AVB, because the arterial repolarization already happens, it will become faster in this stage, right? So this is cardiac conduction.
For more content, like, share and subscribe to www.i-win.in.